So this paper topic is KS-FER, a kernel sharpening based facial emotion recognition. And during the presentation, first we start with the motivation of KS-FER research. So facial emotion recognition, the necessity of this research, and also next a small introduction about facial emotion recognition and their application and what is the purpose of emotion classification or emotion recognition. And to improve the performance of facial emotion recognition, we proposed a FER system using kernel sharpening. And next we analyze the experiment and results using our system, and we compare with the one conventional system. And also finally we conclude our discussions with some future works. So when we start with the facial emotion recognition, most of the system use 2D images as input, like a raw images from a camera, and the system train the model using that images and classify the user emotions. So when we consider that type of scenario, that type of systems, the major problem related with the conventional approaches are limited features for model training and need a huge data set for model training. So when the most of the systems use the FER 2013 dataset or CK plus dataset for training the model, and they test with their own data, or like in the webcam they test the system. So when we consider this type of scenarios, like creating a data set is the first challenge. And also most of the images are in a 2D image dataset, so only one side view of emotions. So when we consider this type of challenges, like there will be some compromise we have to do for the accuracy or performance of the system. So to improve the performance of the system using a normal raw images, and we introduce some type of image processing techniques and enhance or extract more features from a raw image value, more extract more features from a raw image, and train the model and classify the result. So that is our key idea of this research. So to improve the performance of FER system, we proposed a kernel sharpening based FER approach. So this proposed system reached around 99% of classification accuracy. So when we start with the FER research, driver's emotions provide crucial information for safe driving. So the major application of facial emotion recognition is in autonomous driving system. So when the autonomous driving system use the driver's emotions, we can prevent the road accident, or we can reduce the quantity of road accident or something, or we can give better performance to the autonomous driving. So when we consider a FER system, so normally the system classify the emotions like happy, sad, anger, surprise, disgust, fear, or neutral. So when FER system maintain a classification accuracy, it also a useful information for a vehicle safety. So that is our key idea. So to improve the FER system, we need to consider the existing systems and their challenges, and how we can solve some of the challenges using some type of techniques. So the existing FER approaches uses raw images. Most of the system uses raw images. So there are some challenges like need a huge data set, lack of features for training, and poor classification result. To compensate or to improve this performance, we proposed a kernel sharpening based FER approach, and our system reached around 99% accuracy. So here is our proposed FER system using kernel sharpening. So first we start with the RGB image, our raw image from a camera, and the next step is we do foreground extraction. So we remove all our foreground, our background, and we just crop and extract only the faces, and then we convert it into gray images. This is to reduce the computational complexity. So when we use the color images, the system need more time to train the model. So to reduce the training time and to reduce the computational complexity, we convert it into gray images. And next is we introduce the kernel filtering. So basically the kernel filtering is like enhance the edges and add some contrast to the image, and just use only the required information for our emotion recognition. So after kernel filtering, we used our fit machine for cropping and resizing the image, and the fit machine is our previously proposed system, and we apply these images dataset into our deep learning model, and the model classify the user emotions. So here is our result of kernel sharpening on user emotions. So we start with we consider 7 emotions: angry, neutral, disgust, sad, fear, surprise, and happy. So we did a kernel sharpening image processing techniques, and we converted into our raw images into a new form of images, which gives more features to the deep learning model. So here is our previously proposed fit machine. This machine is used for image cropping and resizing the images. And next is our Xception model we used for classification. So here is the architecture we used for our emotion recognition. It's a basic Xception model. And here is our classification result. So we compare our proposed kernel sharpening based FER approach with a conventional approach. So in the conventional approach, we used raw images, and we just did foreground extraction without kernel sharpening, and we use the same system configuration and same model configuration, parameter values, everything. Only the image size, input size is different. Like for our proposed approach, we used 48 by 48, but the conventional approach, due to the foreground extraction and color image values, so our input size is little bit different as compared to our proposed approach, but the remaining all system configuration, everything are same, and we did our classification. So from these results, we can understand our proposed approach gives very accurate classification results than the conventional approaches. So here is our classification result, and we compare our proposed KS-FER system with the conventional FER, and the accuracy we reach around 99.1% as compared to conventional approaches. Conventional reached only 82%. So when we conclude our research, like we proposed a KS-FER system for emotion recognition, and proposed kernel sharpening FER utilized the foreground extraction and kernel sharpening of the facial images, and the Xception architecture used in the proposed KS-FER provide real user emotions and classify the user emotion accurately, and achieved around 99% of classification accuracy. So in the future work, we have to introduce Gaussian blur and unsharp mask image processing technique for better accuracy. But here our system reached 99% accuracy, but the dataset, the images are very small quantity, and when we do in the real time, the performance is not very accurate. So to improve the performance, we need to introduce more image processing techniques and improve the FER performance. Thank you for your attention.